Hello and welcome back to Maths with Mitch. Today we're going to be looking at plotting quadratic and other graphs. And you'll see from the sketches there, you might have seen some of those before, and they're the ones we're going to be looking at. So let's make a start firstly. Let's go with the one from the title, Quadratic Equations. So a quadratic equation, what is it? So firstly, it is an equation with an x squared term in, and you might see it in this form, ax squared plus bx plus c. The a, b and c, they could be any number, and they are the coefficients of those terms. So to be a quadratic, it has to have an x squared term, so it has to have a with a value. B could be 0 and you might not have an x term. Likewise, c could be 0 and you might not have a constant term, or you could have a value for both of those. So let's think about an example. So we might have y equals 2x squared plus 4x plus 1. So that is our quadratic equation that we're going to use for this example. Now if we want to plot it, we have to get our x and y coordinate points and put onto a graph. So you might be given the area of interest for the x values, or you might think where are they going to be, and you can do either side of the 0 point, and that might generally be the right place to start. So we're going to use -3 to +3 in this. And we're going to put that value for x into this equation. So if we were to pick out the first one, so we can say y is 2 lots of -3 squared. Remembering that you're using that the positive or negative term in front of the number, plus 4 lots of -3 plus 1. So we can times that all out. Remember, a minus times a minus is a positive, so when you square that, that's going to be 9. We're going to have y equals 2 lots of 9 plus, we have here a -12 plus 1. So then say is 18. A positive and a negative, that's going to be a -12 plus 1. So 18 minus 12 is 6 plus 1, that's going to be 7. So we can then say the y term is 7 when x is -3. And we can repeat that for all those values of x, and that will give us the following numbers. That's a +1, -1, +1 again, 7, 17, 31. So they are our x and y coordinate points for this graph. So let's draw them on. So I've drawn some axes here. Now you want to draw the axes with the correct scaling that's going to allow you to put the points on. You might see that 3 and 31, that's not going to fit on my axes, but we're not going to worry about that too much. So we'll still get the general shape that we want to look at. So let's plot those points on. -3, 7. Let's go with a nice red. -2, 1. -1, 0, 1. 1, 7, 2, 17, and 3. It can be up there. Now the first thing for these is it's not a dot to dot. You're not drawing straight lines between the points. You want a nice curved line, and you might see that we've got a turning point at the bottom here. So that's now it's not the most fantastic freehand drawing, but you can see there that a quadratic is going to give you this nice U shape with a single turning point, and it's going to be generally be a symmetrical graph that you're going to get. Now the exact nature and the scale of it's going to be different depending on your your a, b, and c terms. You might get a much wider U. Likewise, you might get a much narrower U. And remembering that turning point is going to be at different positions also. Depending on A, B, and C, your turning point might be more like this. So a quadratic, it's going to be in different places around the axes. It might have slightly different scales in terms of how sharp it goes up and down, but the general shape is a U shape, and that's what you should be taking from this. So a quadratic is generally a U shape. So next one, let's now look at a cubic. So a cubic is where we have an x an x squared term. And again, it works the same with a, b, c, and d. They're all different coefficients of the terms. They could be 0, and it just means that you won't have that particular x term in your equation. So let's do the same thing. Let's take an example. Let's do y equals 2x cubed plus 4x squared minus 1. So here you can see that in a standard cubic there are 4 terms, and in this one we've only got 3 terms. So you can see that we don't have the x term here, so c is 0 in this case. But that's the equation we're going to work with. We're going to do the exact same thing. So we're going to do the x and the y's, get the points for the graph. So we do the same process. So last time we put this minus 3 here into the x's, and we're going to then repeat that through for each one to get all the values of y. Now if we do that, we get these numbers, and we can follow the same process we just went through, so we can plot those onto a graph. And here we are again. So this is our y, this is our x, and we can plot our points on. Let's go for a nice blue this time. So we've got minus 3, minus 17, minus 2, minus 1, minus 1, positive 1, 0 is minus 1, 1, 5, and 2 is all the way up here. So we have a much more interesting shape this time. It's not as simple as a U, and we have to think about how to draw these lines up again. It's all about a smooth curve. It's a continuous function that you're drawing here, this cubic equation. It's not straight lines, so you want to make sure that you're drawing nice curves through these points. And there, what we have is a general shape that you're going to see for a cubic. It's a generally going to be an S shape. So you can see the S shape there. Now again, A, B, C, and D, they all might be different numbers, and you might get different variations. So you might have one that's a lot more pronounced as an S shape, like that, or as you see with the blue one, it's a relatively flat shape. But again, this S could be in all different places around the graph. Might be up here, and that will all depend on the values of A, B, C, and D. But takeaway point is a cubic is generally an S shape. So if you're not seeing that and you've got a cubic equation, then you've potentially plotted something incorrectly. Next one, let's look at a reciprocal. So we said in arithmetic, reciprocal was the opposite of a number, so 1 over a number. So the reciprocal of 3 is 1 over 3, 1/3. And here with our example, we've got 1 over x. So that's our reciprocal equation, our algebraic equation, and we've plotted the x and y values out there. Now the key point here is that 1 over 0, you can't say that's infinity. 0 goes into any number an infinite amount of times. So on a graph, that's going to be a vertical line. And it depends if you're on the left or right and what side you're approaching it from as to whether you're going to be going towards a positive value up towards infinity, or whether you're going down towards a negative infinite value. But infinity in itself isn't a straight line. So we can again plot those numbers onto the curve. So let's do a lovely orange this time, and let's plot our numbers. So minus 6, and we have 1/6, be roughly here. Minus 4, a quarter being 0.25, because we've got decimals on the scale here. Minus 2 and a half, which is 0.5. Minus 1 and minus 1. And then we said at 0, that was going to go off to either positive or negative infinity. But we can see here we're approaching, our line's going to be approaching a negative infinity. So we know our line's going to go off in that direction. If we just move down slightly there. and we can do the rest. So 1, 2, a half, 3, third, 4, quarter, sixth. Yeah. Okay, and now we can do our lines. And again, we said here 0. We're approaching it from this side. It's going to go off to negative. But here, when we look at it from this side, if we draw a line up, again, try and go through the points, not like me. And we know at 0 we're going off to infinity again, so we're going to be heading up in that direction. And we can do the same here. So that's the general shape we're going to get for a reciprocal. We're going to see that split curve around the 0 point, because 0 is where you're going to get a line going off to infinity, which is a vertical line. And depending on how you're approaching it, determines whether you're going off to a huge number or off to an extremely negative large number. So that's the general view you're going to get of a reciprocal. Now again, we did 1 over x. Your k number could change, so you might have a value greater than 1 divided by x, and the exact shape that graph takes up will be different, but it will generally be the same curves that you'll get with this split curve. So let's go on to number 4. We have an exponential. So an exponential is something in the general form there, y equals k. Now k can be any number, and then to the power of x. So let's follow our exact same process that we've been going through for the rest, and we'll see if it has a general shape to it that we can explain through an example. So let's do y equals, let's do 4 to the x. Going to follow the exact same process, put your different values of x in there and get your corresponding y. And we will get, that's a 6. There we are. So we will now plot on the graph, we'll follow the same process we have done. So minus 2, 0.0625, minus 1, 25, 0, 1, 1, 4, and 2, 16. And once again, let's put a curve in. And I'm going to do that one again and see if I can get a continuous line that looks vaguely like a curve. There we go. And that is going to be the general shape of an exponential. Because you're doing something to the power, and that power is increasing each time, it's going to be moving upwards, and the rate of change is going to be accelerating. So your gradient is going to be changing as you move along the x-axis. So you're going to see that general shape of something exponentially increasing. Or if you had negative, it would be going the opposite way and it would be decreasing. That was graphing quadratic and other equations. Takeaway points: a quadratic will look like a U shape on your axes. The exact position will be determined by A, B, and C values. A cubic will generally be an S shape, and again, the exact shape of that will be governed by the A, B, C, D values. A reciprocal is going to be a split graph, as you can see, and that's going to be because of the 0 point, where anything divided by 0 is going to be an infinite number and a vertical line, so you need to look at which side you're approaching it from. And then an exponential, you're going to see a change in gradient in either the positive or negative direction with the value of x. So when you're sketching or plotting these graphs, they're the general shapes you're expecting to see, and if you're not, you can do a little check and go back and see if you've got the right numbers in there. So thanks for watching the video. Please subscribe to the channel and join me next time.